Hi everyone, I'm gonna start now. Thanks for coming to my talk. Quick show of hands, how many people here use Kotlin? Yes! How many people don't use Kotlin yet? Okay, nice. That's really good to know, thanks. My name is Shegun. I'm an Android engineer. I'm originally from Nigeria, but I live and work from Düsseldorf in Germany. In the next 40 minutes thereabout, I'll be talking to you about Kotlin. I'll be doing a brief intro about like a comparison between imperative programming and functional programming. I will be talking about functions in Kotlin, mostly lambdas, and talking about how they work under the hood, and talking about some standard library functions that could make our Kotlin journey really easy. And I'll be talking about Kotlin and Java interoperability. It's just a big word for working together in the same code base. Yeah, sorry, I forgot to ask, how many of us write Kotlin? No, how many of us write Java in Kotlin? I do. I'm just trying to get adapted to the functional style of programming, and it's not as easy as everyone would think, and I'm going to share some things about it today. To start with, imperative style of programming is a paradigm that defines the actions you're about to carry out on your code in terms of steps, like how it's done. Functional style, on the other hand, talks about what exactly is being done. So it reads really fluently when you see it. This is like the major difference between the two paradigms, but there are actually more differences that we'll talk about. So for example, if you wanted to print the even numbers between X and Y number, in Java you typically iterate through, use a for statement, and then you do if this happens, then you print. If you had to do this in Kotlin or any other functional programming language, you would use a range function, and then a filter function, and then a map. This really reads just like English language, like start until end, filter, it's modulo 2 is 0, and map and print. It's very fluent. Another difference between the two paradigms of programming is that immutability isn't really encouraged at the language level in imperative programming languages. Like Java, for you to achieve immutability, you have to actually take steps. Like you have to make your classes final, you have to make your methods final, you have to make your variables final, and things like that. But in most functional programming languages, it comes out of the box. Also, instances of classes, structures, objects, they are first-class citizens. So things you can store in variables, strings, integers, they're first-class citizens of normal imperative languages. But in functional programming languages, functions, in addition to all of this, are also first-class citizens. We'll talk about shortly as well. Imperative languages use loops, method calls, and conditionals to actually write the body of the code. Meanwhile, in functional programming languages, there are functions that you actually call to do most of these things. And imperative programming languages mostly allow side effects, and functional programming languages encourage to have pure functions. Pure functions are functions where, given the same set of inputs, you always get the same set of output. Functions in Kotlin, let's start with that. Like I said, they're first-class citizens in the programming language, and what this means is that they can be stored in a variable, just like your integer, strings, whatever type. They can take functions as parameters, so a function that can take another function as parameter. And they can also return a function. And together, these last 2 points are what's known as the higher order functions. So it's really a thing with functional programming languages. They have a feature called higher order functions and stuff like that. So to talk about higher order functions and lambdas, typically on Android, we want to perform actions on different operating system versions. For example, you want to do something that the API is only available on Android P. You typically want to do write a method like this, at least Android P, and then here you pass in the body of what you actually want to execute. And here you write the code, you do the SDK call check, and you call your function. To use it, it looks like this. It's just a block of code, and you put your action in there. So let's look at the structure of the function. The action, which is that has the parentheses and return an arrow to unit, is called the lambda, and it's the function that here you can see that it has no parameters and it returns unit. Then the function itself now is what we can refer to as a higher order function because it takes another function. So it qualifies to be a higher order function. In my journey to learn Kotlin, there is something that's really been helpful, and it's been to take a look at generated code. It's very easy to find in Android Studio. You just go to your tools, Kotlin, and then check the bytecode, and then you can decompile to Java and to see. So it gives a better understanding of what goes on under the hood. And if we look at the generated Java code for this lambda, for this high order function we just wrote, we say it's translated to a normal void function, and it takes in a parameter called function0. I'm going to talk about that shortly. And then it executes the body of our code, which is nice. Except that every lambda in Kotlin is actually an object in Java. And this is not great for performance. Imagine if you had to call this a lot in a loop, for example, it means you're creating an object every time, and that's really bad. Like I said, each lambda in Kotlin translates to a function object in Kotlin. And there are a couple of interfaces, like 22 of them, that Kotlin provides. So function 0 means that the lambda has 0 parameters. Function 1, it has 1 parameter. Function 2, all the way to 22. And this means that you cannot have a lambda with more than 22 parameters in Kotlin. So if we try to improve the problem that we just discovered, there is a keyword in Kotlin called the inline keyword. What this keyword does is that it marks the method as inline. And we call the method, we put the body of our code. In this case, it's the print statement. We just want to print that I'm on Android P. If we look at the generated code, we see that the body of the code of our lambda is actually copied into the execution site. So in this case, there is no function end interface. And this is really good. We get rid of the overhead of creating an anonymous function in using the lambdas, which is really good. I'm going to also talk about some other interesting concepts that you might need to know when working with lambdas. First is the no inline keyword. Just like the inline function we just saw, it's possible to have more than one lambda function, lambda parameter in a higher order function. So let's say we want a fallback method for our function in case we're not running an Android P. But for some reason, because of our specifications, we do not want this method to be inlined. We have to explicitly tell Kotlin compiler that do not inline this method for me. And we use that with the no inline keyword. The next concept I'd like to talk about is the non-local returns. Typically in Kotlin, in lambdas, Kotlin does not allow you to return from the non-local scope. So local return is like you're returning from the closest scope to the line of execution you're returning from. For example, it's like when you break from a for loop in Java, you're returning from just the scope of that for loop. That's like a local return. Any return that returns from the main method body, it's the non-local return. So normally in Kotlin, you can do local returns. You can return from a specific lambda. You can return from a filter. You can return from a for each. But you can't return from the entire function. We can see why this is possible. This is not possible shortly. So meanwhile, in inline lambdas, if you have an inline function, it's possible to return. And if you remember, we said the inline function actually copies the body of the function into the call site. So there is no nested scope within when you're using the inline function, and that is why it's possible to return from non-local scopes when using inline functions. The next concept I'd like to talk about is the cross-inline keyword, and it's used when the lambdas that you pass into your function are not directly used in that function, but they're used in another context, like maybe in another thread, in another execution context, or in another object, or in another anonymous class. Thank you. For example, sometimes we want to wait for layout on Android before we can measure the height of a view or something like that. And so you want to write an extension function for the view class, and you pass the action to execute when the view tree observer has completely laid out the view. We cannot return from here because if we try to return in the body of the lambda, it's unclear. Are we returning from the lambda? Are we returning from the on-global layout? Are we returning from the function? It's really unclear. So the Kotlin compiler does not allow you to do this. And before you can even put a lambda in a different context than the body of the function, you have to use the cross-inline keyword. And that's why we have that keyword there. The next concept I'd like to talk about is the standard library functions. Kotlin provides a really extensive standard library functions. There are a lot of them. I keep discovering new ones every time when I'm writing Kotlin code. But I want to talk about some 4 ones that are really popular. Some people call them scoping functions. I'm not really sure why, but I think it's because it restricts the access and availability of some members of whatever you're calling that method on into a certain scope. So outside that scope, it's not available. So I guess that's why you call it scoping functions. So the first one is let. If we look at the function signature, it's like it takes a parameter or a lambda function that's called block, and it executes it. So the lambda function, and then there's something called receiver. The receiver in Kotlin is the object on which you call the method. In this case, it's with the using generics is the T. So if we look at an example, we have a client that is nullable, and with the client we can get the email, and we want to send an email with the mailer. So you see that in this place, the object where the receiver in this case is the email, and is available in the scope as it, which is really interesting. And it's also possible to rename this it because it's really confusing. Send message it, it's a bit weird. And I actually recommend to actually rename these variables to something that is actually more readable and understandable at a glance. So you want to let, if the email is not null, then let us send this email with the messenger, you know? It reads really fluently. A closely similar one is the run function. It's similar to the let function we just saw, and it just runs the block of code, just like the let. But the difference is that the kind of lambda we use in the run function is a bit different. Here it's a function literal with a receiver. What this means is that we have access to the members and the functions and variables in the T scope, the class itself. So if we're in the scope of, I don't know, maybe a context, we will have access to everything that we could normally do with a context. And a sample usage here is like, say we have a method to perform transformation and we want to run it on a variable called name. We run it, and then in this scope, in this block, we have access to the name as this. So we're in the context of this class itself, the class string in this case. So we can do everything that we would normally do with a string, and we'll reference it with the this keyword. And the interesting thing about this is that the return type is whatever is last in the code block. So in this case, the return type is string, which is the transformed one from the operation we did there. The next interesting function I'd like to talk about is the also. The also is really nice because it kind of encourages the builder pattern in Kotlin. So normally in Java, if we wanted to make this developer class builder pattern, we would have to have a builder class, and then we do developer.builder.setName.loveScart videos.start and then .build, you know. But in this case, it's really simple. We just do developer.also. And the interesting thing is that within the block of the also, we already have access to the developer object that was created just before that block. And we can reference that receiver as it in this case. Or like I said, we can rename the it into something easily understandable by your teammates. So the next concept I want to talk about is the apply. The apply is probably the most popular one of them, I don't know. It's similar to also, except that the way we access the receiver is different. We access the receiver as this, because we're in the context, and you can tell from the signature of the lambda function that it's a function literal with receiver. So there are some interesting things to consider when you're using these functions. One is to actually avoid overusing them, because the readability can degrade really quickly. Imagine you have a block of let, if, when, let, apply also, and then it becomes a real mess, and it's difficult to read. So you should avoid overusing these functions, even though they're really nice. You should consider renaming the it into something better whenever it's possible. Like, there's almost likely a better name to call that it. It doesn't always read nice. Sometimes it reads really nice, and you may want to leave it. Other times, no. There are a lot of other standard library functions. There's a take if, take unless, with, etc. So let's look at some of them in action. So we have this block of code. We want to send a message to a client. We have the client, the message, the mailer, and we're doing null checks and then getting information, and then null checks again before we finally send the message. If we're going to write the Kotlin equivalent, it's a lot shorter. And here we use the take if, and we're checking here if the message is not null. So the take if is one of the special functions that comes with Kotlin, and here it returns it passes this block if the condition is true, and we get the personal info, the email, and then we use the let that we just saw, and we also rename the variable here, and it becomes really easy, functional. This is a typical functional block. There is no ifs here, there is no else, there is no all the weird stuff from imperative programming, and this is like what I try to achieve whenever I'm writing code with Kotlin. So the other parts of this talk, it's what I actually think is one of the most important parts of working with Kotlin. It's the Java and Kotlin interoperability. In case you're wondering what the island is, Java is an island in Indonesia and Kotlin is an island in Russia. So it's important to us as Android developers because the Android APIs are still written in Java, and so we're always calling Java API. And there's some things we need to get at the back of our mind when working with these APIs. Also, most likely, we already have code base that is in Java, and the task now for us is to migrate to Kotlin. So from time to time, we'll be calling Java code from Kotlin, we'll be calling Kotlin code from the Java code. So the first concept I'd like to talk about when you're considering interoperability is nullability, and I'm going to do like a quick quiz. If you know what, in terms of nullability, what the string in the middle, what it means, you just shout out. Sorry? Could be null. Could be null, awesome. How about the one on the left? Not null. How about the one on the right? Cert, not null. Sorry? Okay, we're almost there. So, like you said, the one on the left is non-nullable. It can never be null. The one in the middle is nullable, and the one on the right is what's known as platform types in Kotlin. At this point, the Kotlin compiler has no idea whether it's nullable or not, so it's really confused on what to do. This is really, really important because we were told that Kotlin will save us from null pointer exceptions, and if you have a lot of Java Kotlin operations in your code base, and you end up with this type, you're prone to get null pointer exceptions. And then your manager is going to ask you why you pitched a lie to the management. So types are really, really important when you're working with Java and Kotlin. So a string in Java, in the Kotlin world, could mean two things. It could mean a string that is nullable or a string that is not nullable. We don't know. But there are some interesting tools that have they've been in existence for a while, but I guess we just never really used them. And they're the nullability annotations. There's the nullable, there's the not null, and yeah, that's it. There are different versions of these annotations. There is the ones from the Java specification requirements. There's the one from the JetBrains library. There's some from some other libraries. And they basically have the same signatures and they have the same purposes. And Kotlin is smart enough to be able to detect this. So if you have this method on the left in Java, it returns my name, and we annotate it as not null. In Java, if we call it, we don't need to do a safe access because the Kotlin compiler already sees it as a non-nullable object, which is fine. But the story changes if we annotate the same method as nullable. The Kotlin compiler already sees that this object could be null, and it sees it as a string that is nullable. And that means we have to do a safe access to access this, to call this method, which is really nice. On the other hand, we have this same function without any annotation, but it returns null. If we write this and we just say my object.getName.length, it compiles fine. The compiler is not going to say anything. But by the time we run, then we get a null pointer exception. And that's when the manager is going to get really angry. Also, the same block of code, we're not changing the function, but we just put a question mark and we access it. It also compiles fine. So what's going on? The thing is, the Kotlin compiler already translates the nullable annotation into the nullable type in Kotlin, and the not null annotation is translated into the non-nullable type in Kotlin. And the type that we have, the rogue one, is the one that the Kotlin compiler has no clue, and which we should actually try to avoid as much as possible. So the key takeaway from here is that if you have Java methods that you are calling in your Kotlin code, go there today, not necessarily today, but start putting the annotations in these methods. There's actually a use case of this that was in the Android support library very recently. In API and support library version 27, the activity from the fragment, if you want to do fragment.get activity, it's actually nullable in real life because the fragment could be detached from the activity. But in the code, it wasn't annotated, so you could just do fragment.activity.do something, and then it will crash in runtime if it's detached. So they did an upgrade in subsequent versions. They put the annotation, and now you have to do a safe call to access the activities from a fragment, unless you use the require activity or require context, which returns a non-nullable type of context. So we talked mostly about calling Java code from Kotlin. Now let's talk about calling Kotlin code from Java. Most of us are not going to be in this situation because we're not calling Kotlin code from Java. But if you happen to be writing APIs or SDKs or code that is shared amongst other teams in your company in Kotlin, which I recommend you do, these concepts will become really important because some things change how they appear when you're calling from Java. I'm going to start with the package level functions. You know, in Kotlin, you don't have to have a function in a class. You can have a function just in a file, you know, which I think is really nice. So we have this interrupt-demo.kt file, and we have the function getName that returns my really nice name. And we call this code from Java. What happens is that we're not able to find interrupt-demo as a class. Instead, we find interrupt-demo.kt as a class. So to access this method, we have to do interrupt-demo.kt.getName, which is a bit ugly, I would say. So to fix this, there is an annotation called JVM_name, and it's an annotation that tells the Kotlin compiler what the name of the class should be when it generates it. So if we go back and add the JVM_name to this file, and we use the interrupt demo, which is the name we actually want, when we call from Java, then we're able to call the actual name that we want, which is really good, and it's something you should take into consideration if you're ever using package level or top level functions in Kotlin. Another interesting thing about this annotation is that it could be applied to normal functions. For example, we have, this is a regular class in Kotlin, we have still this getName, but for some reason we want a different signature for this. We want getInterruptName. When we consume from Java, we don't even have access to getName. The Java doesn't see it. Meanwhile, the Kotlin can. So depending on your use case, if you have like methods that have the same, almost the same signatures, you can use the JVM_name to actually differentiate between them so that there are no clashes and things like that. It's really useful. The next one I want to talk about is the add JVM static annotation. Kotlin doesn't have static methods, but we have objects and companion objects and all the likes. Now, when we call this from Java, they appear slightly different from when we call them from Kotlin. So take, for example, we have this object string utils, and we just want to turn a text into uppercase. If we call from Java, it's this really not so good looking line of code, string utils.instance.uppercase, and then this is really bad for an API if you're writing. To fix this, we add the JVM static annotation, and we're able to access the uppercase just like a static method, like a normal static method in Java, which is really nice. So if you ever have to do like initializers for your SDK.init, you should consider using the JVM static annotation just so that your Java, the people implementing your APIs in Java are happy with you because they know where you live. Another interesting use case, which was something I stumbled upon recently and I thought it would be nice to share, is with static providers in Dagger. If you use Dagger, you know it's possible that you have your provides method in static your providers in static methods. So we have, let's say we have this, and we're trying to provide an API service interface within a companion object. This is not going to compile. First, let's look at the generator class to actually understand why that's happening. We'll see that, first of all, the method we're trying to provide is in another class. It's in a class called companion. And it's annotated with provides. And if you use Dagger, you know that you can only use the annotation provides in a module. So that's the first point Dagger will break down. And also, there's also another problem. In the actual module we want it in the repository module, the code is not even there, it's in another class. So that's actually a problem. Now to fix this, first to fix the issue of using the annotation to provide outside the scope of a module, we annotate the companion object as a module, just so that Dagger can try to find it. And then we annotate this with JVM static. And what does this JVM static do? It creates a copy of the function that is annotated with, and creates it in the main class, and also has a copy in the companion class. So when you're calling this code, normally from Kotlin, you could call it repository module.companion.provide API service. It works fine. You could also call repository module that provides API service. It works fine either way. But Java can only do, it's only going to be able to call this one this time because, and also Dagger will be able to provide this dependency because it can find the return type that's annotated with the provides. And it's just going to ignore the companion because it's not registered anywhere. The next annotation I would like to talk about is JVM overloads. As the name suggests, it helps to generate overloaded methods, sometimes for constructors or for regular functions. So let's take a look at this function with default values. It's a class, that's a Kotlin class. It's a point xy coordinates. It defaults at the origin. If you call this from Java to create this point, there are two ways we can do that. We can do point is new point, or we can do point is new point and we pass in the values for x and y. So we have to specify none or all of the parameters. If we decide to add the JVM overloads, then we also have to add the constructor keyword because that's how you annotate a constructor in Kotlin. So if you see the generated code this time around, it has the overloaded methods. The empty constructor, the constructor with a single value x, and the constructor with x and y, which is really good, which is what we actually want. We don't want to provide, if you're writing an API, you probably want to provide as many flexible methods to create variables. So if you call from Java, we can create a new point with no value. We could create a new point with one value. We could create new points with x and y coordinates. And I think this is really important. So it also works for other functions that are not constructors as well. And this is really nice because if you're writing an API or an SDK that's going to be consumed from other places, you typically want to avoid repeating your methods. So you want to write one function that has default values and then you use the JVM overloads and it's going to generate overloaded functions for you. You know, when we're working with this kind of functions in Kotlin, we don't have the problem. We can simply ignore the default values. But when you're working with Java, you just can't do that. And that's why the JVM overloads is really important. And there are actually a lot more JVM annotations. There's the JVM field, which you use when you want to expose a member from your Kotlin class as a field in Java. There's the JVM suppress wildcards that you can use when you're using generics in Kotlin and you want to port it to Java. There's a JVM multi-file class, and there are so many others that I'm not just going to talk about in this code. When I'm trying to stay up to date with Kotlin, I just watch a lot of KotlinConf videos. I follow the Kotlin hashtag on Twitter. I've subscribed to the Kotlin weekly newsletter. And I use the official website as well. So to recap, there are like three major things that can help us really improve our Kotlin experience. And first one will be to really understand the functional paradigm of programming. It's a little bit difficult to understand. The only way to actually get better is just to keep practicing it and just keep trying to criticize your own code, like critique your own code. If you write something, you just think, how can I make this more functional? Am I writing Java in Kotlin again? How can I make it better? Are there any standard library functions I can use? And the next one we want that can help us improve is to actually look at the standard library functions. There are a lot of them that are really helpful. There's an extensive collection framework that is really helpful that we can look at. And then we also have to keep some points in mind with Kotlin Java interoperability. And yeah, that's it. I have the links to the slides already on my Twitter, so you can get it if you want. I don't know if anyone has questions. I think I finished ahead of time. Yeah.
Thanks, so when you're talking about Kotlin and Java interoperability, why do you think that Kotlin doesn't just assume if you don't have annotation that the variable is why does it assume that it's not?
I think I do, but the short answer to that will be that, Yeah, this is going to be the answer because in Java, a string is a string. But in Kotlin, a string is not really a string. A string is either a string that is non-nullable or a string that is nullable. So the Kotlin compiler has to have a way of inferring from the code you're calling. So in this case, we use the annotation to do that. And luckily for us, the Kotlin, the folks at JetBrains, they recognize a lot of different versions of the nullability annotations, the ones from the support library, the ones from the JetBrains annotations, the ones from a lot of other libraries. So even if you're not using the JetBrains one, you can use the Android support annotations one. So I guess, does that answer your question? Okay. Questions? No? All right. Thank you very much.